Founded in 1913. 4 water basins. Temperatures as low as -20 degrees. In the Hamburg Shipbuilding Research Institute, different models of ships are tested for functionality and suitability, be that in waves or in the Arctic Ocean. We're now in the HSV's large towing tank. This is a large basin about 300 meters long. Basically, ships are examined here, and we want to know what power requirements these ships have, and is this power requirement within the usual range? The resistance is measured. You have a propeller on the model. You also measure how much power the propeller generates through the water. In the largest of the 4 water basins, sea state tests are being carried out today for new police boats of the Flotte Hamburg. Here we can see how the ships behave in different sea conditions. How does the ship lie in the water? And here it's essentially about what the conditions will be like for the crew on board. The experiments provide important information regarding the future operation of the ships. Simply put, the crew is less likely to get seasick, and on the other hand, of course, it's about the efficiency of the hull. The less resistance the hull has in the water, the more efficient and also more environmentally friendly the propulsion is. The Hamburg Shipbuilding Research Institute has been around since 1913. And indeed, it's not only data and calculations that guarantee a ship's seaworthiness. It's still the case, even though it may seem hard to believe it, that numerical calculations can't predict the behavior of ships as well as model tests can. That's why we usually do tests for all ships, both in terms of resistance and efficiency, but also things like swell behavior. We usually have the large container ships, tankers, but of course also research ships and naval vessels. It's a very broad range. We have almost all types of ships on the seas here in the tank. And since all types of ships are tested here, there's also a special ice tank. Here, the temperature can be cooled down to -20 degrees. We're working on a project in the ice tank today. It's a river icebreaker that's supposed to travel through ice there. Not through solid ice, but through what's known as brush ice, that is broken up ice floes. The icebreaker is pulled through the ice to find out how much power is needed to drive through a layer of ice at a constant speed. We now have a series of times, so basically measurement data that tells us something about the speed at which the model has now travelled, about the speed at which the propeller has rotated, how much thrust the propeller has delivered, and how much torque. And then we look at all of that and evaluate it, and then we can tell the customer how much power his ship needs. A vast array of customers have their models tested here or carry out field studies and test software. But they all have one goal. Ultimately, you want to have confirmation and you want to be sure of the predictions you make, whether on the computer or in the tests, that they're correct and that they correlate with the real ship. So having a water basin is very practical. That's one of the main reasons. You want to know whether it's the optimal ship. And so that perfect ships can sail in the port of Hamburg and across the world's oceans, the Hamburg Shipbuilding Research Institute continues to test countless types of ship in model form.